Okay, greetings to all. This is Dr. M. Shakti Mohan, Associate Professor. In today's video content, we are going to discuss about the combinational circuit design, in particular with magnitude comparator. So, how the magnitude comparator will be designed and what is magnitude comparator? Okay, so how it will make the operation, we are going to discuss it one by one. Okay, so we'll enter into the video. So this is what the basic block diagram of magnitude comparator. So it contains two inputs and it will deliver three outputs. So that is A and B is the two input, and A greater than B, A equal B, and A less than B is the output, right? Okay. So before entering to the magnitude comparator, I will discuss some basics, right? Okay. So the basics of magnitude comparator. Actually, magnitude comparator is a combinational logic circuit, so which will compare the input's magnitude and it will deliver the output, right? Okay, so magnitude means the weight. Okay, so the weight of the input. Okay, so depends on the principle. So the highest magnitude is 1 1, and after that 1 0 will be there, and after that 0 1 will be there, and after that 0 0 will be there. So this is what the highest to lowest priority of magnitude. Okay, so 1 1 having the highest priority and 0 0 having the lowest priority of magnitude. Okay, so it will compare the magnitudes, right? For example, 1 1 is a A input and 0 1 is a B input now. So compare the 1 1 with the 0 1 and it will deliver the output. So what are all the output now? It is very simple. A greater than B, A less than B, and A equal to B. For example, in this case, A will be bigger than B. Okay, so that means the output is A greater than B. So likewise, it will produce the output. So that is the concept of magnitude comparator. It's a very simple concept only. So we'll go into the content page. Okay, so this is what the block diagram, right? So you can see n bit comparator. So there are two input, that is A input and B input. Okay, so A input and B input, and there are three outputs. So that is A greater than B, A equal B, A less than B, right? Okay, since we already discussed, so the highest magnitude is 1 1. It is followed by 1 0 and 0 1 and 0 0, right? So this is high and this is low, right? Okay, so you can see this is the theoretical part. There is a comparator or magnitude comparator is a special combinational circuit designed primarily to compare the relative magnitudes of two binary numbers, right? So now in this video we are going to design 2-bit magnitude comparator using basic logic gate. So here I'm just mentioning the input as a 2-bit input, right? So A1 and A0 having a 2-bit input, and the next 2-bit input is B1 and B0. So now I'm going to compare A1 A0 with B1 B0, and there are three outputs since you know that. So A greater than B, A equal B, and A less than B, right? And by combining the A1 A0, B1 B0, so totally we are having 4 bits of input, right? So 4 bits now. So with the help of 841 combination, I am just writing the input. That is you know that. Okay, so in the previous video we discussed many times in this concept. That is, otherwise it is very simple to write the inputs in a vertical manner. That is for the first input 8 zeros and 8 1, and second input 4 zeros 4 1 4 0 4 1, and the third input 0 0 1 1 0 0 1 1, and the fourth input 0 1 0 1. Likewise we will mention. Okay, so now the process is very simple. You are going to compare the A bit with the B bit, and depends on that the output will be, you have to mention it here. Okay, so you can see 0 0 and 0 0. So in this case both are same. Okay, so if it is both are same now, A equal to B you have to put 1, and the remaining two output you have to put 0. That's all, right? And you just compare the next input 0 0 and 0 1. So compared to 0 0, 0 1 having the highest priority, that is highest magnitude. So that means B is bigger than A. So that means A less than B you have to put 1, and the remaining two you have to put 0. So likewise you have to perform the truth table. So once you completed the truth table, what is the next part? Yes, you are correct. The K-map simplification. Okay, so you have to put the K-map for A greater than B, and A less than B, and A equal to B. Okay, so once you completed the K-map, if the equation is very lengthy means, so try to reduce the equation as much as possible with the help of Boolean algebra. So that also we already discussed in the previous video. So if you want that, you just to check with that video. So hope that will satisfy you to get a better knowledge regarding the simplification of Boolean algebra, simplification of Boolean function using Boolean algebra. So once you've completed the K map, so you can get the output as that is a greater than b. So this is what the output, that is a1 a0 into b0 bar plus a0 b1 bar into b0 bar plus a1 into b1 bar. So likewise, a equal to b. So this is what the output, that is a1 bar a0 bar b1 bar b0 bar plus a1 bar a0 b1 bar b0 plus a1 a0 b1 b0 plus a1 a0 bar b1 b0 bar. Okay, so since I already told you, so if the output of the K map is somewhat lengthy now, so there is a way to minimize the equation with the help of Boolean algebra. So here I'm just reduce the equation. Okay, so see, these are the steps to reduce the equation. So final equation for the a equal to b is a naught x nar b naught into a1 x nar b1. Actually, x nar means the output equation of x nar is equal to y is equal to a into b plus a bar into b bar. This is what the output equation of x nar. Okay, I hope you remember. So that also we have discussed in the previous video, that is a universal gate and gates video. Okay, and the final output, that is a less than b, the output is a1 bar a naught b naught plus a naught bar plus b1 b naught, sorry, not plus, a naught bar into b1 into b naught plus a1 bar into b1, right? So now we can get all the three outputs. So the next part is very simple. So you have to draw the logic diagram for the output equation, right? So like stick diagram. Okay, so here you just to mention this is what the logic diagram for a greater than b, and this is what the logic diagram for, this is the logic diagram of a greater than b, and this is the logic diagram for a equal b, and then this is the diagram for a less than b, right? So this is how you have to you just to design the magnitude comparator, right? I hope you understand the today's video content. So in today's content we have discussed about the basic principle of magnitude comparator and the highest priority of magnitude and lowest priority of magnitude, and how the output it will be delivered, and how to design the magnitude comparator, all we discussed. I hope you understand. Thank you.